All right, terrific. Okay, so hello everybody, welcome. This is a conversation that really came together when I was talking to our guest here, Bill Hesbach, and I asked whether he had ever produced a video that just allowed him to explain some of the core concepts of the idea of the condensing beehive, which is something that he's talked about a few times in American Bee Journal articles and he's given lectures about. But we realized that there was no readily available, video source that we could point someone to say, here's Bill in his own words explaining his current understanding of what we know about this concept. And so our hope today is that we can pull some of that together and wind up with a nice, decent little video clip that folks can take a look at. So as I've said, my guest here is Bill Hesbach. Bill, do you want to just introduce yourself briefly and tell folks why you are a trusted and valued source of beekeeping information the whole world over?
Well, I'm not sure if I can articulate an intelligent answer to the second part, but for me, I'm a sideline beekeeper in Cheshire, Connecticut, and I have an interest. I have an engineering background. I have an interest in science and technology, of course, and my specialty in bees is about biology. And so when I began my career in beekeeping, I've always stayed on the scientific side, and I've done a lot of research about any kind of question that popped up in my mind. So I began writing some of that stuff for Bee Culture and then American Bee Journal, and I've now have quite a few articles out in those magazines that explain some of my positions on things. So that's it. I'm just a beekeeper here in Cheshire, Connecticut. It's really cold here today, and it will be below zero tomorrow. So we're in for some cold weather, and I think that's about it. I do have a certification as a Master Beekeeper from the Eastern Apicultural Society. I'm the president of the Connecticut Beekeepers Association here in Connecticut. We have about 600 members. I am on the board for EAS, and I'm also the state representative for the American Beekeeping Federation from Connecticut. So I have several different hats I wear in addition to writing articles and keeping bees.
Well, I think you've done a pretty darn good job of answering my second question.
All right.
So the concept we're here to talk about, and I do want to keep us focused because I think you and I could talk all afternoon, is this idea of the condensing beehive.
Yes.
Where does the idea come from? What is sort of the core concept here, and how does it differ from ways that other people try to keep their bees?
Well, the concept comes from these emerging ideas about how beekeepers feel about moisture. And the question is whether or not they should control the moisture or play an active role in trying to control the moisture in a colony, or allow the bees to manage their own hive gases. And I come down on the side that says beekeepers probably don't have much expertise in being able to control the moisture in a colony when you compare it to millions of years of evolution, where bees, if they weren't able to manage moisture in ecology, they wouldn't exist, right? They grew up in cavities. We're talking about cavity nesters now, right? Cavity nesting bees do a really good job of being able to manage hive gases. They have tools to do that, and they use them, including fanning at the front of the colony or using propolis to seal cracks. There's lots of ways that evolution has provided tools for bees to manage moisture. So either you believe that you're the person that can interfere with the colony's natural functioning with hive gas regulation, or that allowing the bees to do it is the difference between these two sort of emerging camps. And I think we're beginning to get a strong participation on the condensing hives side. Now, why do we call it that? And the reason that we call it a condensing colony is because what occurs is bees manage moisture vapor from the cluster in a certain way. The analogy is maybe a condensing coil in your hot air furnace or your cooling system, where you pump in a cool gas and it cools down a framed plenum which you pass your hot, moist air over from your house. And when the hot, moist air hits that cool plate, it condenses moisture out. Right? And that's what occurs in a colony if you don't have a space above the cluster that's above the dew point. So in an air conditioning system, it's designed to condense moisture out. In a beekeeping colony, if you design that hive right, you can keep the space above the bees higher than the dew point, and no moisture will condense out and fall onto the bees, right? So the cycle of condensing, the cycle of moisture is a condensing cycle inside beehives. Whether or not it drips back down on the bees and kills them, or else
Right.
you put insulation on the top to keep that dew point high enough so no condensation happens over the cluster. Those are the two sort of camps.
So one camp is, and I guess maybe we should take one step back about the biology for those that aren't up to speed on it. It's important to remember that when your colony is sitting there eating honey, they're manufacturing heat, which is what's keeping them alive. But by doing that, by breaking up sugars and metabolizing it, they're also manufacturing water. And so the water vapor that your colony is constantly exhaling, that's the water that enters into this system. And the two camps are, should we vent all of that water away, or should we accept and allow that it's going to condense somewhere? And so as long as it condenses in the right spot inside the hive, that might actually be perfectly fine and maybe even give some advantages to the colony. Is that a fair summary?
Yeah, it is. And thanks for clarifying that. Because yes, actually the moisture we're talking about is moisture, as you say, that occurs, it's biological moisture, comes from the metabolic action, cellular action in bees as they ingest food or try to keep the colony warm. Mm-hmm. And the interesting part about, we think about this in terms of a winter cluster mostly, but it occurs all year long. And the only problem, there's no problem in the summer because the temperatures of the air are high enough to carry lots of moisture without it condensing anywhere. Mm-hmm. And in the wintertime, that's not the case. In the wintertime, you have a real warm center cluster. And warm air, as some of you may know from your high school or college meteorology courses, that warm air can handle a lot of moisture, can carry a lot of vapor because the molecules in warm air are farther apart, the nitrogen molecules and the oxygen molecules, more space for vapor to accumulate. And that's what exists over the cluster. So in a winter cluster right now, say for instance, and there's some brood in my colonies at this point, so they're keeping the brood nest in the 90s somewhere, that volume of air can carry a lot of moisture, and then it'll come up, it'll naturally rise through the combs, through the cluster, and the first things it hits is what's above it. Now, that's where we start to talk about how a condensing colony works, what's above the cluster.
And that's the important thing, is that this idea isn't just talking about what happens in a bee colony in nature, it's that what you have are a series of beekeeping management decisions to make a hive that is designed to allow this process to happen one way instead of just getting rid of the moisture and hoping it never happens anywhere at any point.
Yeah.
Right.
Yeah. So
can you walk through sort of what are the key points when I've got a hive in front of me and I want to make it a condensing hive for this coming winter? What am I going to be doing?
Well, what you're going to be doing if you want to make it a condensing colony is you're going to make certain that the space above the top of that cluster, which is pluming out a lot of hot, warmer, moist air, does not go below the dew point. Now, the concept of a dew point is very simple. You know, you put a hot glass out and you put a cold glass out on a hot summer day and you see it moisture collects on that cold surface. So if the cluster's temperature and the roof above it are at a point where no moisture will condense on it because the surface is warmer or above the dew point, just like if you take a glass, cold glass out into this weather, no moisture will accumulate on that. Mm-hmm. So if you keep that surface above the cluster, above the dew point, nothing condenses there. So this plume of hot air comes up, hits that warm space, warm insulation. We'll call it insulation because that's exactly what it is. and then it spreads out along that insulated surface until it finds cooler air. And at that point, it can condense out. All right. So what a condensing colony does is it keeps the space right above via insulation that keeps the temperature above the dew point. It keeps that from any moisture from condensing right above the cluster. And that's pretty evident if you have if you look at it, a condensing colony's operation in the wintertime, you can see the space above the cluster is completely free of condensation, but outside of that, there is condensation.
And so one important, and you've already said, one important feature of achieving that goal is upper insulation in the colony.
Right.
And if there was no upper insulation, you would have condensation, but you'd have condensation right where you don't want it because it would be dripping back down onto the bees.
Right.
And so, when I talk to people about insulating their own hives, one of the often, their complaints are, they say, well, bees in nature, they don't need any insulation. So why should my bees need it in the box? Is something wrong with these hives? And what I have to remind people of is, well, in nature, they're living in a wooden hollow tree cavity. So the walls are about this much wood and the ceiling is about a tree's worth of wood still on top of them. So that's an awful lot of insulation on the roof of that colony. So you don't have that, as warm air rises and as the top of that cavity is heated, there's going to be very little cold that's able to sort of penetrate, or very little heat will be able to escape out of the top because there's an entire tree in the way. Whereas the walls are going to be considerably colder. Yeah. So upper insulation in a manufactured beehive is going to be something you achieve with, a piece of foam, or I think I have So we just got sent this demo, so I'll use it because I've got it in my office here. So this is a BeeSmart insulated inner and outer cover system. But the nice thing about this is that they've cut off a corner, so you can see that you've got this piece of plastic on the bottom that is all the bees will ever see. But you've got this nice big piece of very, very stable foam on the top, and then you've actually even introduced an air gap, in the outer cover.
Yeah, which
created this very robust amount of insulation on the top, and then put little to none on the outside walls of the colony. And that is something I want to talk about.
We can talk about that. If you look back before we had quality insulation materials, when folks wintered bees in cold climates, they noticed right away that the inner cover was full of moisture and dripping back down on the bees. So their solution was to then add extra ventilation.
Moisture was the enemy, so they just needed to
moisture is the enemy, never realizing that moisture is not the enemy. Moisture is in the cycle of the way bees naturally live. Now, the other thing about condensation that you have to understand as beneficial when you allow it to occur in a colony outside the top of the cluster, right? So if you could control like that particular insulated top that you showed will keep moisture from occurring, liquid moisture from condensing out of the cluster's heat and dripping back down on the bees because it has all of that nice insulation on it, right? So that'll keep that from doing it. But if you have just an inner cover, of course, that'll be the temperature of the ambient temperature. Now, what the piece that's missing that most people don't get about the condensation part is that there's latent heat that develops from condensation. So there's a beautiful natural heat recovery system that's built into a condensing colony. Once the condensation occurs, it occurs, but it has to give off the heat that it carried out to that area. So get a load of that. I mean, so it's like it's a kind of a difficult concept, but it's understandable. You've got a hot air cluster coming up. It can't release any of its heat against the surface right above the cluster because it's insulated and it's above the dew point, but it can release its heat as it goes out. So condensation, as a matter of meteorology or beehives or any way you want to look at it, the physics of it is that when you condense liquid moisture out of vapor, it gives off latent heat. Now, that's an interesting natural occurrence that bees have evolved with. Their adaptation is to recover their own heat.
Right. And maybe an easier way to explain that for those that haven't totally followed what you're saying there is it's easy to understand that when we have a lot of ventilation in a colony, you're going to lose, you've got this warm air rising that's holding all of this moisture. As that warm, moist air leaves, you're going to lose moisture, you're going to lose heat, which is just present in that air.
Right.
What you're saying is that in addition to that heat, there's even more that's being lost because the heat that is going to be released when that water vapor recondenses is also going to be retained.
Yeah.
When you're not venting it out
both parts of it.
Atmosphere.
Yeah, you lose the. I mean, you might
bulk heat.
Yeah, you might want to argue that when you ventilate a colony in the wintertime, you put them in a constant survival mode.
Mm-hmm.
Now, that's, by the way, where I think the whole mythology about how much honey you might need to overwinter came from. Yeah, sure, you're going to need 100 pounds of honey to get a colony through the winter in the Northeast if you provide ventilation. And if you don't provide insulation, you have to provide ventilation or your bees will be dead early in the year because the moisture will condense above them and fall back down and kill them.
Right.
So,
and
that's why that occurred. That's why people said,
right. The observation of moisture on a wooden inner cover was enough for them to try ventilation as the first attempt, but it turns out it might not be the best one. And that's an important point you made that I always try to emphasize to folks too, is when you've got a honeybee colony inside a box, honeybees, whether it's winter or summer, are excellent climate control devices, right? The entire colony is spending a lot of its time and effort making sure the brood temperature is the right humidity, the right temperature. They're controlling a lot of that. And they have a lot of levers they can pull, fanning their wings or buzzing their flight muscles to control those things. But that when you've got a colony that is controlling its temperature, if you put them in an uninsulated box and you open the doors wide and there's a bunch of drafts blowing in, sure, with enough heater fuel, they can keep burning it and they can keep generating the heat and staying alive. And so the cost of having an upper entrance, of not retaining any of that heat that's otherwise going to be retained if you allow condensation of big highly ventilated colonies, is that you need to basically pay them in honey. Is that the honey is the extra fuel they burn, just like my house with no roof on it and no wall on it. I need to turn my heater a heck of a lot higher and burn more fuel.
You can go to your upstairs in your house and open up your windows and you'll see a bigger fuel bill.
Right.
But you're a healthy person. When you add, so let's go back, and say, listen, we're talking about 50 years ago or 75 years ago when these habits were unfortunately established against the will of, by the way, some very forward-thinking beekeepers early in this process. And one of them was a beekeeper called Ed Clark. He wrote a wonderful little book anybody can look up on the internet and read about condensing colonies 100 years ago. Mm-hmm. So if you think about how bees manage the temperature and airflow in a colony, it's in microbursts. They meter out the kind of temperature change they need, a little bit of difference in the tightness of the cluster. Small metered changes, biologically driven with millions of years of evolution behind those exact movements. So what we do is stick a popsicle stick under the inner cover, on the telescoping cover, with absolutely paying no attention to the wonderful biology that can do that for us.
Right. We've just put them in a wind tunnel, and
we put them in a wind tunnel.
50 or 100 years ago, just because they could survive that, it doesn't mean that they were thriving, that was necessarily the right solution. Right. And as you've got pesticide pressure, varroa pressure, other disease pressures, any of the things that bees struggle with, it only adds to it if you're not giving them the ideal environment in the winter.
Yeah. So my sales pitch on condensing colonies, it's not, you just can't say, hey, it's not your grandfather's colony or grandmother's colony. What it actually is a completely different biology that now the bees' biology, the basic biology, the genome is basically the same, but they have to survive in a completely different ecosphere with all of these viral loads,
Right.
pests.
Which
And
doesn't mean
you
that
know,
it doesn't mean that grandma or grandpa's bees wouldn't have done better if they had been put in a condensing colony too.
they may have, yeah.
If
I
it
mean,
right.
a lot of them were.
So let me just because we're both numbers guys, let me ask you this. So we said this notion that you need 100 pounds of honey in order to get through a Northeast winter is a commonly quoted one. But how much honey do you leave with your bees in what I presume are condensing colony setups?
Yeah, so my bees will probably, if my bees go through 23 pounds to 40 pounds a winter, depending on the size of the colony, that would be a whole lot.
Okay, and these are full-size colonies, not
yeah, yeah. Oh, no,
groups.
these are full-size colonies. Yeah, they might go into this. They might go into the fall with 9 seams of bees, 9 or 10 seams of bees. Really robust, nice heavy-duty colonies. Now they use most of those stores in the beginning, October, November, and then when they get down to a place where they're in a condensing configuration, there's a couple of other things that occur. Maybe we should just talk about the science of that just briefly.
Sure,
so
sure. Yeah, absolutely.
So the one thing that you make certain you relieve your bees of when you do lots of ventilation is you take out the heat, and you also take out the carbon dioxide that bees are manufacturing as part of their biological process. And of course, that's the other total misconception that beekeepers have about bees or insects in general. We suffer from hypoxia. You can die from that, right? You get a higher percentage of serum carbon dioxide in your blood, and you can't metabolize functions, and you die. Right. So we all know that. That's why we have detectors in our house to make sure that our heating appliances don't kill us. Well, that's not the way the insect world works. In the insect world, they get into a high CO2 condition, but they go into a low metabolic rate. So they switch their metabolism, and they do that naturally as part of their evolution. I mean, they don't hibernate, but they can change the metabolic rate, their metabolic rate. And a high concentration or a high-ish concentration of CO2 in a bee cluster that's not being ventilated performs that function for them. In a real tight cluster, they lower their metabolic rate. They sip small quantities of energy then to stay alive.
Mm-hmm.
So,
and you can anesthetize a queen bee to get ready to instrumentally inseminate her with CO2.
Will not kill her.
This is not unlike the same thing. It's just that high CO2 level is going to slow and calm and settle the cluster when they don't have anything else to otherwise do.
And then, by the way, now that you mentioned that, one of my untested but interesting theories that I've been trying to find some science behind recently is that whether or not that hypoxia, that induced hypoxia in the middle of a bee cluster, isn't the thing that's actually stimulating the queen to lay little brood patches. That's how we get queens that we inseminate to lay. Right? We give them a dose of CO2 and they come back and they start laying. Well, it occurred to me that these conditions occur under really tight cluster arrangements, but then when they break out of that, the queen will go back to laying again. Is that a signal she gets from this particular, evolutionary biological adaptation to
interesting, or even just the release of that CO2 control might be one of a number of triggers of coming springtime that the colony can then use to figure out what's going on.
Because we've never been
able... It's easy for me to figure out what the weather is when I can go outside and I've got a window to look out, but they're inside a dark box or a dark tree cluster all winter. So how do they know when spring is just about ready to spring?
Absolutely. And no one's ever thought to look at that as folks. No, there's plenty of science about the effects of carbon dioxide on bees. No question about that. And we also know from our queen rearing ventures that you can use, you do use carbon dioxide all the time. So so is that the signal that gets bees to start laying again?
Terrific.
You asked that question, Dave. That's a good one. We could answer that. Back to just to make a point now that bees are metering their regulation and in minute quantities. They're moving exactly in concert with what they're sensing from the environment, and that you dispense with all of that when you decide that you're going to be the person that controls moisture. Now, I'm an advocate of controlling moisture with ventilation if you're willing to go out and try to figure out how to adjust it. But what we do is we just bulk apply it as if just one big gap will do it all, and we know that bees don't work that way.
Right. It's a huge amount of ventilation, because our goal, or at least many people's goal, is not the correct amount of moisture, it's zero moisture.
Zero.
And you've talked about, you mentioned that one important thing that you lose when you don't have a condensing setup is heat. Another important thing that you lose is CO2. But one important biological resource that you're taking away from the colony is moisture.
Yes.
And something that a lot of people don't understand is that even in winter, bees are going and drinking some of the condensed moisture inside their hive if it's available, and then making use of that. And so,
well, so those droplets are hanging around inside of a colony in the wintertime. So bees have a chance to break cluster.
Mm-hmm.
When they break cluster, it's a matter of survival to go and find some honey for them to then ingest. Well, they just don't ingest honey; they have to thin it. So those droplets of water that are hanging around in the colony are what they use to thin honey, to feed the queen, to feed themselves, trophylactically feed, whatever they do they always thin honey. When you see bees in the wintertime come out of the colony, the first thing they do is start lapping up water they can find everywhere.
Right. My doctoral advisor, Tom Seeley, once gave a lecture, and, someone asked him, he was talking about thirst and thirst regulation in bees.
Yeah.
And he says, how thirsty do bees really get? Like, sure, they go and they forage for water, and maybe in the desert they need it, but I keep my bees in New York. So is there really much risk of my bees ever being thirsty? And he said, look, you've read my work. You know how long I've been studying bees. I've spent a lot of time watching waggle dances in observation hives, right? like the one behind me. He said the most intense waggle dancing I've ever seen, the most desperate waggle dancing I've ever seen, was in springtime, as soon as it was warm enough for a few bees to go out and start foraging. And it was a water forager. It was a bee saying, finally things are warm enough. We can go out and get some liquid water and bring it back in, because that's the thing we need for a hive living in a climate controlled, human environment like that. And I think any colony probably is experiencing really severe thirst if all of that moisture that, as you say, they've evolved to have is suddenly taken away from them.
It's taken away from them, right? So, so if you believe that you should control the moisture with ventilation, then you've dispensed with a whole bunch of natural biology. And if you are of the mindset that you might want to let them manage those hive gases by themselves, you're up against a large population of beekeepers that will tell you that their colonies will suddenly die of moisture, because what they observe in a colony, I think you and I have talked about this before, is mostly when their bees die, they see a lot of moisture in the colony. But then, of course, they don't realize that the moisture comes from the bee's body themselves, which is probably at 89% water, maybe, very high percentage of water. And that water has to go somewhere. If it was in the bees' bodies, it'll come out and rest on the comb. And then you get mold growth and all of that. So, bees.
Right.
So the analysis, postmortem for a lot of beekeepers will say, listen, my bees were totally wet, and that's why I got to put more moisture in them. And there was mold all over the place. That's why I have to keep the airflow going in the colony. But the fact is that when bees move air in the colony, they control all that. And then if they're alive,
the metaphor I use to sort of explain that to people is, if I stood up in my office here and then had a heart attack and collapsed on the rug, if you came in a week later, there'd probably be a lot of moisture on that rug. It wouldn't be the moisture that killed me. That's just a consequence of my body no longer retaining all of its moisture.
I know, but you could understand the confusion in that diagnostic.
Right. It's an easy diagnosis to make. You say, why are my bees dead? Well, they're all wet. That clearly wouldn't be good in the winter. It must be the moisture that killed them.
And I see a lot of, mold around. It's probably from that. Yeah.
Right. Or the mold
didn't get enough ventilation.
Right. So I'll add more ventilation, and surely that.
I'll add more ventilation. So I think we covered sort of the basics on, what the cluster's doing in terms of its hive gases. And if you want a full sort of spectrum of what's occurring, then you have to take into consideration what we talked about in terms of latent heat, the condensing of actual to liquid moisture on the outside away from the cluster, how that's beneficial for the bees to use in the wintertime when they need a source of water, when they can't or won't fly out of the colony, but they can move a little bit.
Right. They can go to the outer wall where it's condensation.
They can move a little bit. Right. They can move a little bit, and they can get a hold of some droplets of moisture and bring it back.
Now, I'll say this just because, at Betterbee, I sort of help folks who are interested in buying wooden hives, but also buying polystyrene hives of a couple of different designs. And so those are much better insulated hives. Does a well insulated hive wall interrupt or cause problems for the condensing hive framework? Do we want a really poorly insulated wall on a well insulated top, or does good insulation across the board still serve the colony's interest if we don't have a huge amount of ventilation?
Yeah, so if you're going to model your condensing colony after what you might find in a tree, you would insulate the sides.
You want insulation everywhere, but certainly the most on the top.
Right. And keep in mind, of course, that honey itself is quite a good insulator. So if it'll get cold right outside the cluster, gets cold anyway. So you're really not making heat in the colony by adding insulation to the outside walls. But what I like to do is meet the wall insulation with the top insulation so that it mimics a tree. So in other words, there's a whole cycle, there's a whole envelope of insulation around the bees. And that then allows for those surfaces, it's still cooler on the sides, but it's a 75-25 mix. You're going to lose 25% of the heat out of the sidewalls. And this is from, my envelope engineering when I was consulting as an environmental engineer. And 75% will go out the top. So you're still going to, lose moisture. But yeah, I make a sleeve that goes over the colony, and then I have an insulated top that meets that sleeve so that there's no binding in it. If you separate them, put a crack around that, you're adding ventilation.
Right.
So I try to keep that box as airtight as possible. You cannot get it airtight, right? So there's always leaks. But in my opinion, the better job you do of making a total envelope of insulation, the more you will approximate their natural habitat.
But if you do have wooden hives, then it's the top insulation that's really sort of the heart and soul of the condensing hive.
Right.
Structure.
If you don't do that, then
then
you don't have a ventilator.
Both the upper insulation and the lack of ventilation, or lack of an upper entrance, or if you do have an upper entrance, one that's sort of so long and convoluted that you'll have little to no air moving through it.
Right.
But ideally, none at all.
Ideally, none at all, because then you have an envelope. Then the bees are more capable of being able to manage the flow of air in that colony. And if you let them, they'll propolize the whole space down for you. I mean, they give you every hint you want to let
about what they're trying to do to get ready.
What they're trying to do, and I mean, if we could follow their lead, and I'm an observational beekeeper, and I always tell everybody I try to teach, and we have 600 members in the Connecticut Beekeepers Association, so I'm always on some kind of teaching role, or in some kind of a teaching role, and those I always try to tell them that you try to get as close as you can to a model that would suffice to allow bees to handle ventilation their own way, and then you observe what happens. You have to make that other step. To follow your observations, not a prescription. And almost all of 2 areas in beekeeping are totally prescriptive. One is the addition of ventilation, and the other is the quilt box.
And the quilt box really is essentially the pinnacle of engineering to maximize ventilation of moisture out of a colony.
Right. Well, I'm glad you said that. because that's not the purpose of it. That was never the intended purpose of it.
Really?
But that is what it became.
Okay. Can you talk through what the intended purpose and
Well, so
maybe
the intended, well, so the intended purpose of
let's
it.
start with what a quilt box is for people that might not know.
Okay, so a quilt box is a box that's filled with an absorbent material. Let's just say you put a medium super on top of your colony's top bars in the wintertime. If you had a double hive configuration, you would take the inner cover off and you would put this quilt box on it. The quilt box usually has a fabric underneath. And then inside that quilt box, say it's a medium box, it would be filled with something that you are allowed to choose. Wood chips, whatever, I don't know, whatever you want to put in there, which is interesting in itself, right? So you can
that you have that much option for something. It probably suggests that
as many
it hasn't been
kind of material you want. And then the innovation that's occurred over the years was to drill holes in it then. And the point was to let all the moisture out. So quilt boxes came along with Waré, right? The Waré hive. You know, that wonderful French beekeeper who thought he wanted a people's hive, right? And that's the name of his book, right? Beekeeping for All, I think, is or Beehives for All or something is the name of the book. And in there he tried to make a colony look like a tree, and he noticed that he needed insulation or on the top, so he invented a quilt box. So if you just think about the name, quilts are not, they're not for moisture.
They're not about moisture wicking. They're about keeping you warm.
They're for heat, right? They were quilt boxes were originally designed to provide
just an economical way to have upper insulation, which is exactly what we're talking about.
Right. And you could easily have just put foam on it, but there wasn't any foam when I was invented. So the quilt box came into beekeeping parlance, and people started to notice that or started to think that this would be a great way to take moisture out of the colony. And
so the idea there is simply that the warm, moist air goes up through the fabric, sort of moves through the wood chips. Maybe some of it gets absorbed, and then if you've drilled holes and put on a screen, that you then have sort of a plume of warm, moist air that's being ejected out of the top of the hive and is now no longer going to murder your bees with moisture. That's the idea that I've certainly heard espoused.
Yes, and what most people, I hate to say this, but I don't think very few people understand, or beekeepers understand when they're making a quilt box, the nature of diffusion, which is that's the principle you're using when you pass vapor through different objects. So vapor in a quilt box diffuses into the, so it's not wet, right? So there's no moisture there. There's no liquid mortar. Wood and liquid moisture work one way. So let's say you're putting wood chips in there. But with a quilt box, it's diffusion. So the water vapor never stays in the wood. It moves through it, right? So it doesn't collect it at all. The only time it's collected is at the very top of a quilt box. Beekeepers notice that top might be wet. But 1/2 inch below that, the wood chips or whatever they put in there are completely dry. Because
it's condensing.
It's condensing.
If they
because
insulated above their quilt box, then they probably wouldn't see that.
They wouldn't see that, right? That's exactly right. And anytime you drill holes in the side of a good piece of equipment, you've ruined it for other uses. And whenever you add cold air into that space in that quilt box, you're going to get condensation.
You're promoting the condensation by allowing it to condense inside.
Yeah, so I think the concept of quilt boxes is, in its original concept for quilting, for warmth, be fine. And you capture, or the diffusion goes through the chips and you lose it. So you're taking away the moisture. Yeah, well, so you won't get any condensation on the bottom of that fabric because it won't occur. Because of diffusion versus condensing, right?
Right.
You won't condense until the chips are cold enough.
Right, and you've got a warm cluster underneath. You've got
Right.
relatively warm air hitting that, and so it's well insulated above. That's what the wood chips
It's well
are
insulated.
doing. So
and then
yeah.
But now you get into the really tricky part. What do you put in there into the quilt box for? Here's the real problem I see with quilt boxes. What do you put in there for your material that you want to diffuse vapor into? Almost every material out there has a different diffusion coefficient.
Right. Is it cheesecloth? Is it a tightly woven silk? There's going to be very different properties.
Very different properties and very different diffusion rates.
Right.
Right. So how do you figure out? This is why, by the way, there's no science on quilt boxes. I spent a day, 2 days, maybe looking through everything I could. Maybe you can find something or somebody else could find something. Send me the science on it, because I could see no peer-reviewed control studies or anything on quilt boxes. Because for you to actually do that, you'd have to figure out what kind of material you want to put in them. Of course, the best material in the world for a quilt box is wool, right? Wool diffuses out and gives you back heat. That's why you could, the structure of the way that, it's a physical thing with wool. The fibers are in such that they actually give heat back. You can have wet socks on and you feel warm with wool, right? They wick stuff out. So do you use wool? Do you use, and by the way, hardwood chips and softwood chips diffuse at different rates. So you can't figure out, in my opinion, with the way people are using quilt boxes, what they actually do.
But setting the diffusion aside, just any quilt box is going to potentially improve the survival of the colony, and part of that might simply be that they're, for the first time, putting insulation on top of their bees.
Yes.
And so now they've insulated above, under the inner cover and above the cluster, and so that might very well achieve a lot of the condensing hive goals, even if they were trying to ventilate. If they've got such a low diffusion rate through their fabric that it's hardly going to be losing much moisture.
Yes, if they have a if they have a high diffusion rate on their fabric. Some people use screen. You can use canvas. So for screen, there's no the diffusion value is 100%.
But to the beekeeper who has used a quilt box and said, "Wow, I'm getting better performance of my bees. I have better spring buildup. I have better overwinter survival. I was trying to wick a bunch of moisture away and vent it out, but maybe that's not even what they achieved. Maybe what they achieved was just good top insulation that's brought their hive more into configuration with a condensing hive setup than if they had just had an inner cover with an open notch and a bunch of drafty air blowing through all winter."
Yeah, I wish we had the data.
Right.
And I think
scientists who aren't me, because I've got other stuff to do. Somebody go do the study. Maybe I'll do it next year.
Yeah. No, I suspect you're correct. I suspect that there's some liquid moisture on the outside frames with a quilt box. But I think that just the plain old slab of insulation would achieve the same thing and probably give you more of a moisture cycle inside the colony.
It's certainly more similar to most of the natural colonies you encounter that do not have two entrances. And if they do have a secondary entrance or an upper entrance, very often it gets propylized over.
Yes.
So again, if you ask the bees how they would like to be kept, which in my experience is never the wrong way to keep your bees. If you ask the bees what they want and they tell you, generally I'm hard pressed to find a reason to disagree with them. Because as you say, they've been keeping themselves a lot longer than we've been keeping them. So they probably have a decent idea of how to do it well.
So I'm not opposed to quilt boxes. I just don't think that folks, we know enough about how to configure them to make them optimal.
And you're opposed
maybe
to
they don't have
one,
to be optimal.
You're opposed to some of the philosophy that goes into somebody building themselves a quilt box, because some people are doing it very much from the perspective of moisture is the enemy and it must be pulled out of the colony and defeated. And that you would disagree with.
I would disagree with that, because that wasn't the intent of quilt boxes to begin with. They were just to put a warm surface over the top of bees. And the second part is that I think if under the right circumstances, if you put insulation on top of your quilt box, on top of the chips, and you didn't bore holes in it, you would end up with a lot of insulation.
So we've talked about advantages of the condensing hive. We've gone through the basics of it. So essentially, what you would advocate at its simplest form is no upper ventilation, yes, upper insulation. And then better versions of that are going to involve even reducing ventilation from the lower entrance. It's going to involve increasing insulation around the entire upper portion of the colony, allowing CO2 to build up and letting the bees control that ventilation of both moisture and fresh and stale air. Are there other features, or are there other beekeeping practices that you would recommend, or is that really the heart of it? It's really just understanding that philosophy of where the moist air is going and what you want it to do within the confines of the hive.
Yep. The added benefit is that a beekeeper who begins to give it that much thought gets more in line with the biology of his bees in a lot of ways. Not only from the condensing portion, but then they begin to observe other behaviors. Like what's going on? It breaks
that mindset of I am the master of these bees. They are my livestock, and they'll do what I tell them. It turns into, what are they doing? How can I help?
Right, and that kind of perspective. So that if you manage to walk through that threshold at some point in your beekeeping career, you're going to start to look at everything that occurs in the colony in terms of what's occurring outside of it. The available pollen, the available nectar. You'll see brood moving in concert with those natural sources, and you're not hive centric anymore. You move out into a very, very large area, which really informs your beekeeping at that point. You get good at it. You get really good at that. I say, look at the beekeepers whose bees survive every year and follow their example. And most of them are not ventilating their colonies and doing things that are not in concert with bee biology. Assuming they're not moving them to a warmer climate,
Right. Yes. So sometimes their bees are succeeding because they're taking them to South Carolina.
They move them to a warmer climate.
Right. No, the advice I always give is you need a mentor. Go to your local bee club and get someone who can give you advice. But don't get advice on your varroa management, on your overwinter preparations from the loudest person in the bee club. Get advice from the person who has the best overwinter survival.
Absolutely.
That's the one you really want to be.
That's true. Yeah.
Into. Right.
And then of course, I don't abandon that philosophy during the summer. I leave my insulated tops on all year long. And if you had that one from that you showed,
the Bee Smart one,
the Bee Smart Hive top, you could leave that on all year also.
Right, and it'll prevent hot sun from heating up the top of the colony in the same way it prevents them from losing heat. As I said, honeybees are a climate control device in some ways. And so whether it's too hot outside or too cold outside for them, the more insulation they have, the better they can do it. My heating bill is lower if I have roof insulation, but my air conditioning bill is also lower if I have insulation.
Right. You don't take the insulation out of your walls when the season's change.
Right. I want a nice insulated pocket because then it's a lot easier to control it separately from the outside. Right. Well, Bill, I know that we could go on all day, but I do want to try to keep this as sort of a nice, concise video where folk can just get an understanding of this concept. So I think we've hopefully achieved that. Do you have any parting words of wisdom on sort of what we know or what we have yet to know, or do you advocate that every beekeeper, no matter where they are, commercial or hobbyist, give a condensing hive setup a try, or are there caveats or there downsides you want to warn about?
Well, so the condensing colony concept is not a commercial beekeeping concept. I mean, they just, they already do lots of things to keep their colonies alive, including
bringing them to warmer climates,
warmer colonies, and they, that's it. My talk about condensing colonies, my belief is not, it's not just mine, by the way. I share this with guys like, Tom Seeley's doing some really interesting work right now, about it. And then of course we have Derek Mitchell out that's been leading us through some of the physics of it, so the thermodynamics of how it works. I certainly know from a building envelope standpoint, nothing is different. You have a heat source and then you manage moisture and airflow in certain ways. As a matter of fact, if we could do what I did in residential and industrial settings, we would make the building so airtight that nothing leaked out of it. And then we brought in the amount of air we wanted.
The active ventilation is controlled by the building designer, or in this case is controlled entirely by the bees.
By the bees, and they will do exactly what I accomplished with gasket material, insulation stuff, visqueen barriers, and then so they do that with propolis. Very simple. They cover up all so that's so I would say that it's basically a backyard beekeeping thing, or somebody who has. I was up to, I don't know, maybe what I was running them. I never had to run more than 30 production colonies for honey to meet my demand, my market demand.
Sure.
So those were always,
even for a sideliner, or for a commercial guy, if they were so inclined. If I was a commercial beekeeper and I wanted to keep my bees alive in a cold climate, there's no reason that I couldn't take lessons from this sort of alternate philosophy of how to deal with moisture in a colony during the winter.
If you wintered your beers, bees over
right. If you wintered them in a place that had a season that you could call winter,
you can call winter, then you have to deal with it in some ways. Well, the folks that this from following the literature, they the more and more there's no bees are not kept outside in Canada. They go, the commercial beekeepers are all keeping their hives in buildings and keeping them exactly for, so that kind of happened. So,
and in some ways that might be achieving some of the same goals. If it's high CO2, if they're controlling the ventilation of those buildings, that is sort of a way to achieve what you've talked about. Is it, you say, if I'm not going to allow the bees to control their ventilation, I need to control it myself. Well, if I put them in a climate-controlled potato cellar, maybe I can control it just as well as they could.
And they do.
But otherwise, let's let the bees do their jobs.
So, what I warn beekeepers that get into this and want to try it out, if you got 10 colonies, try 5, or 4, you will meet a lot of resistance. Don't talk about it in your bee club, especially. You really can, because the concept of condensing colonies is about, I don't know, I think I started talking maybe 7 years ago, 8 years ago, or something like that. I was a lone wolf at that point, but now I've got a lot of support around,
Well, and you said it's a 100-year-old beekeeping concept, right?
Yes, it's 100-year-old.
Like you invented it.
I did not invent it.
You were a new advocate.
No, I'm not a new advocate. I did bring my building science background over to it, which I thought was pretty relevant. And so I can't think of anything else. I do want to say at this point, you don't have to build any of this equipment. I was forced to build my sleeves and everything. It's all out there. You sell. Betterbee is a wonderful supplier of polystyrene colonies. I don't know who you're carrying at this point. License.
We've got the licensed polystyrene and the BMAX. We also sell insulation. We have the Nods Bee Cozy insulation wrap. We've also got a vinyl insulation wrap. So there's wide range of options available. So it's less about the product. It's not like you're trying to sell.
You don't have to invent the product.
It's the philosophy. It's this understanding that instead of looking at moisture as the enemy, in some ways it's looking at ventilation as the enemy, as long as the moisture condensing right above the colony and raining back on the cluster problem is solved another way. And you do that with insulation instead.
And then basically I can't see why backyard beekeepers that are interested in keeping their bees wouldn't want to keep them in a more natural way.
Sure.
It's as simple as that.
Well, marvelous. It's as simple as that, everybody. So, thank you very much, Bill, for agreeing to do this.
Well, listen, I'm the one that's thank you. This is a great opportunity to talk to you and an audience. I hope has a chance to listen to it and just get the idea that maybe they can try this for themselves and see what their results are.
And you do give talks. You are available if a club wants to fly you out to talk about condensing hives. How eager are you to do that?
Well, I've done it all over the country, by the way. So I've given this talk to most of the states on the East Coast, and then I've given it to folks out in Colorado and That's as far west as I've gotten.
So if somebody watches this and they want to try to get you to come out and talk to their bee club or their state association, then
Oh yeah, I go out.
touch
Yeah, I
with
go out
you
and do that. Yep.
and get even more expertise than we've been able to share in just this sort of
yeah.
short
And there's a lot of stuff
about.
to read too. I mean, so you can. There's lots of folks out there at the Tarf up
Yep.
up in Yukon. You know, Tardif, he does a wonderful job with the science on it. It's, you know, I try to keep the science, the real complicated thermodynamics out of the discussion because it'll just discourage people.
It's interesting to you, but maybe not to the average backyard beekeeper.
Yeah,
no, they really want to know more.
It's not about that. It's about something else. So thank you, and thank Betterbee. And I've had a chance to look at a lot of those Bee Smart products, and some of them are very interesting, innovative, and useful to beekeepers. I think I'm running a few in my bee yard here, and
excellent.
And I think that's worth. If you want to take a first step in just an insulated cover, there's a good option.
Right, and I think that's why Betterbee carries them is that we appreciate that generally it's bee focused design. Some of the stuff is, beekeeper focused design. It's something that might make your life easier, but a lot of it is, making an insulated cover that's going to make your bees do better.
Yeah.
So it's not just here's the cheapest insulation we can buy. It's what's the correct amount of insulation, and then we're going to put that in there.
I just want to offer one other thing before we leave is that the Bee Max insulated cover that you sell.
Yep.
Allows for you to put a 3/4 inch sleeve around the colony and just tape it up with some foil tape.
Yep.
And those two surfaces will meet. And
you've built your envelope.
You built your envelope.
Excellent.
So if folks want to use that, that's a very, I had to build all, back in the day, I wasn't thinking about that. And I built all specialized insulated telescoping covers, but it's not necessary because you sell that product and it works.
Excellent. Well, thank you so much for joining us.
Right.
And I hope that folks have found this useful, and that now when you hear somebody in your bee club murmuring in the background about condensing hives and some article that they read a few years ago, maybe this video will lock into place and you'll know what people are talking about.
Okay. Dave, thank you so much.
Yeah, absolutely. Thank you.
Okay.